All right, hello. We're in Chapter 6, Section 2. I'm going to give you some examples of using the normal curve. So let's just jump right into it. We've got example 6.8. The final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Find the probability that a randomly selected student scored more than a 65 on the exam. So if we want more than a 65, that's to the right of 65. So to the right of a value, the value is 65. Area is probability, right? What's the probability that a randomly selected student scored more than a 65? It is 34.46%. B. Find the probability that a randomly selected student scored less than an 85. Less than is going up to the left from 0 to 85. So we went to the left of a value, 85. That one is all the way, right? Look, we have a z-score of 4.4. It's way out there. Because the mean was 63 and the standard deviation is 5, most of the data is clustered below 85. Now, we've said before that a value of 1, a probability of 1, or a 100% probability means absolutely certain. This is where it's a little bit fuzzy here. When we're talking about area under the curve, we're doing an approximation of a probability, right? Is it possible that somebody did better than an 85 on the test? Yes, it is, right? So it is not absolutely certain that everybody scored below an 85, but it is very, 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 very likely. Notice this says that the area is approximately 100, not exactly 100%, right? So we use the normal curve and the area underneath it to estimate probabilities, not always find the exact probabilities. Okay, C. Find the 90th percentile. That is, find the score K that has 90% of the scores below K and 10% of the scores above K. And we have to switch up what we're doing. Right now, I've been calculating an area under the normal curve. We need to calculate a value corresponding to an area. Now, if I want 90% of the values to be the left, then or to be less than, then I want to the left, and I want the area to be 0.9. And there it is. The area is 90%, and the score is 69.41 if we round. Right? So that is the 90th percentile score, just below a 70. Tough test. Find the 70th percentile. Okay, try it. And pause me, go to Staplet.com, click on the normal distribution, find the 70th percentile. Did you do it? Okay, here it is. We're just going to change this to 0.7. There it is, a score of 65.622. Okay, let's do one more, and I really encourage you to try all of these on Chapter 6, Section 2. You really will start to get a feel for using the normal distribution if you do some problems yourself, right? Okay, the golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. Find the probability that a randomly selected golfer scored less than a 65. We want area under the normal curve, plot distribution, area to the left because it was less than, and 65. There it is, 15%, 15.87%, almost 16%. All right, I'll see you in the next one.